not last week. Okay, is it on Tuesday? Okay, on Tuesday, we done the restraint work calculation example for the beam design. But the ones that we only finish is the restraint pin for the ultimate calculation. Okay, so okay, so we done this until this one, combination of shear and moment. However, we haven't done this one, check deflection. So deflection is service ultimate limit state, which is accordingly to the Eurocode 3 Part 1 National Annex. Okay, you must follow this limit. Okay, so means that for the vertical deflection, cantilever should be the length divided with the 180 beam carrying plaster or other brittle finish, which is normally that we pick for the beams, is span divided with the 360. Other beams except purlin and sheeting rail is span divided with the 200 purlin and sheeting rails to suit the characteristic of particle cladding. And for the horizontal deflection, this is you need to follow. Okay, this is basically like a buckling of the column lah. Okay, so therefore, the ones that we did, the ones that we're going to do is vertical deflection for the beam. Okay, for the span is span 360 based on our calculation for this beam on Tuesday, which is the one that we did for this one, this beam. Okay, meter. Okay, the limit for the beam 1AAB will be 4,000 divided with the span 360. So your deflection shouldn't be more than 11.11 millimeter. Okay, that is the limit that you need consider it. Okay, you shouldn't more than 11.11 millimeter. Okay, how to calculate your maximum deflection? Okay, it should be based on this one. Okay, this is the what we call it. This is the formula. Okay, to calculate the deflection of your beam. But remember that this is deflection will be only occurring at the center of the beam. Okay, then you can consider using this formula. If your beam is not occurring at the middle of the center of the beams, okay, you need to calculate by yourself by using the internal and external forces. I mean the energy method, which is you have to. I think you learn it in toss of mark. Okay, firstly you have to consider one beam here, one point load here, and then calculate what is the internal work and external work by get the value of the equations there. Energy work, yeah, this is energy work. Okay, so if the deflection is not occurring at the center, you have to use this type of the method to find what is the deflection should be you calculated. Okay, so for the beam 1AAB, okay, luckily it's occurring at the center because actually you know that is a symmetry loading. Okay, so therefore of course it will be occurring at the center, and the shape of the loading, okay, that's why the shape of loading is very important. You know that for slab 1 or slab 2 is going to be like this. Trapezoid. Okay. Right. So, however, in this formula, it's not directly shown where the shape of the trapezoid. So you can combine it by using this one and this one. Okay, you can see that this one and this one actually will be formed the trapezoid shape. Okay, so when you are using the calculation for the deflection, you have to do some of the combination by using this formula and this formula. All right. One more thing is, okay, when you go for the deflection, again, let me go to the standard first. Okay, if you look at this standard, you may find that it says here, okay, the following table gives suggested limit for calculated vertical deflection, okay, under the cross load combination due to variable load and should not include permanent loads. Okay, the code already given to you that the when you want to find the limit, okay, and then the maximum deflection, you must do the combination of the variable loads but not include permanent load. So meaning that the W here, okay, the ones that we calculate here, okay, we done last time, if W is a combination of the load of permanent and the imposed load. So therefore, when you're calculating for the W for the deflection, you have to ignore the permanent load, just calculating the imposed load. So what is the partial safety factor for the imposed load? So again, that's why Eurocode 0 is important to look, because it says here that for serviceability limit state, the partial factor fraction should be taken as 1.0 except it's differently specified in Eurocode 1 and Eurocode 2, Eurocode 9. So in Eurocode 3, it didn't mention that, okay, the other partial sensitivity should be less or not. Okay, so it's mentioned here, it should be 1.0. So therefore, when you're calculating the value of the imposed load for deflection checking, okay, you must go for the 1.0 QK. Right. So that is the important part. Okay. So meaning that for the slab one last time, 1.0 QK, okay, which is N, okay, we got the value is 1.0. Again, try to calculate one by one first. From the slab one is QK is 3 kN per meter square. Okay. Three kilonewton per meter square. Okay. You got 3 kilonewton per meter square, and your W is 3 kilonewton per meter square times with the half of the 3 meter, which is this is going to be 1.5. So you got the value of this one is 4.5, is it?
Yes, doctor.
Okay, 4.5 kilonewton per meter. So this is the new value of the load to calculate the deflection. Okay, and when you're using this formula, again, yeah, I have to remind you, this value of the W, it should be in kilonewton. Okay, because you know that the deflection should be in the unit millimeter or meter, which is the unit in length. Okay, so that's why actually this W is not actually in the unit kilonewton per meter. This W actually is the unit in kilonewton. So therefore, you have, when you calculating this W, make sure that change it to kilonewton first. Okay, so how about we do it for the flat one first, yeah? Okay, for the trapezoidal, okay, this combination of this one and this one, okay, we're calculating this one first. I put it aside first, okay. So the first shape is going to be this one, this part, like this, which is W. So what is the value of A, B, C here? So A is 1.5, 1, and 1.5, isn't it?
Yes, doctor.
Okay, so this one is 1.5. And then the formula we'll be using is W384EI minus 4L LB squared plus Weber B cubed. Okay, so change this first to the kilonewton. Okay, so we know that W is here is 4.5 kilonewton meter. So just put in the calculation 4.5 kilonewton per meter times with the, you know that it's going to be 1 meter, isn't it? Right. Betul tak?
Yes, doctor.
Okay, so divided with the 384 E. So what is the E? Modulus Young. So modulus Young of for the steel is 210,000 Newton per millimeter square. Okay, times with the I. So what is the I? So you know that what is the section that we used for the beam before? What the section that we pick on Tuesday?
178 times.
Okay, 178 this one. So 178 okay, this one. Okay, so R is the second moment of area, so which is at the principal axis, which is at the major one. So this one 1360, you look at the unit centimeter power 4. Okay, so 1360 times with the 1360 centimeter power 4. Change it to millimeter power 4. So we're going to be times 4. Isn't it?
Yes, doctor.
Okay. So multiply with the H, L. The total L is 4,000 millimeter power 3 minus with the 4 millimeter. Okay. Times with the B is 1 meter power 2 and then plus with the B, which is, okay, so what is the calculation now? What's the value? Can you give me the answer? What's this value first? Calculate this one first. One is 4.5 kilonewton. Okay. What is the two? Can you give me what is this one? And what is the third one? Berapa cepat? Yang ni berapa? Yang nombor 2 ni.
$4.96
This one, this one.
2.
4.96
96 times 10 to the power of 11.
times 10 to the power of 11. Unit?
cube.
Okay, how about this one?
1.097 times 10 to the power of 15.
15. Okay. Unit?
Newton.
Newton?
Per millimeter square. Newton millimeter square.
So you can see that when actually you cancel the units, you will get the value of millimeter. Can you see that?
Yes.
So that's why the W should be in kilonewton. Okay, so what is the value now? In millimeter. So everybody got the same answer?
Madam, I got 2.034.
2.034 millimeter.
Yeah.
So everybody got the same answer?
Yes.
Okay, so good. We done. But only for this shape from this lab one. Okay, so now we need to plus with this one. Okay, so the formula is this one. Okay, I draw it for easier calculation. APA. So what is your W? 3 kilonewton per meter, right? Times with, is it 3 kilonewton? 1. Sorry, kilometer square times with the 1. So you got 3 kilonewton per meter. So your W is here now is 3 kilonewton per meter. W per 2, W per 2. This one is W per A. So this one is your A is going to be 1, 1, 2. Isn't it?
Yes, Captain.
Okay, because this is 1 meter. So the formula will be is W divided with the 384. Sorry, WA divided with the 120 EI. Okay. 16 A square minus 20 AB plus with the 5B squared. Okay. So make sure that the WA should be in kilonewton. Okay, we done this first. We're going to do this first. W, okay. So 3 kilonewton per meter. Change to kilonewton first. So you know that this is triangle. So times with the 1 meter, isn't it? So this is your W. Okay? And your A is 1 meter. Okay, just 1 meter. So change it to, okay, do it like a 1 meter first. Okay? 120 E, 210,000 Newton per millimeter square. Times with the I, what is the I just now? 1360. 1360 times 10 4 millimeter power 4. Okay, and then times with the 16A. 16A square, A is 1 meter, minus with the 20A times with the B plus with the 5B squared. Okay, so I should try to separate this one first, and then this is the second, sorry, and then this is the third calculation.
Doctor,
Yeah,
sorry to interrupt. This one we are calculating for slab 1, right?
yes,
So the measurement should be like this now, right? 1.5, 1 and 1.5. But now we are using 1, 2, 1. Isn't it like for slab 2?
oh sorry, yeah. Thank you, Kat, thank you.
Okay, welcome.
We haven't finished the slide 1, right? Sorry, thank you, Kat, thank you. 4.5. So this is, sorry, so this is going to be 4.5 kilonewton per meter. 4.5 kilonewton. This is 1.5, 1.5. So, okay. So this one will be, is it, sorry. A is okay. So B is, okay, this one 1000. Okay, this one. This is 1. Okay, done. Thank you, Kat. Okay. Still on slide 1. Sorry. So what is the calculation on 1? Yang ni berapa? Lepas buat yang dulu. Ini. Separate calculation. Berapa? Cepat berapa ni? Ni berapa ni? Saya suruh kakak ni nanti berapa?
Doktor.
Hmm?
Yang first tu 10,000.
Unit?
10,125.
10,000.
125.
Unit?
Unit kilonewton millimeter.
Okay. Number 2?
Doctor, 3.427
3?
times
3,
Point.
cat? 3
Yeah.
point?
427
47.
times 10 to the power of 14.
14.
Yeah, 14 millimeter square.
Okay.
Times
Times with the number.
Doctor, millimeter square.
Oh, this is number 2, right?
Uh-uh.
Sorry. Number 2 or number 3?
Number 2.
Number 2, this one. You calculating this one or this one, cat?
The top one, because mm square over mm square multiply with mm4.
So therefore the unit is
Newton millimeter square. Sorry. Yeah, Newton millimeter
okay.
square.
So what is the third? The third one.
One point one times 10 to the power of 7
1
millimeters
point.
squared. 1 times 1.1 times 10 to the power of 7 millimeters squared.
Millimeter square. Okay. So if you cancel out, you still can get the value in millimeter, right? Wait, who give me the answer this one?
Salah kira madam.
So how much is the value, this one?
I get 5,000. 5,062.5
Unit?
kilonewton millimeter.
Hmm.
5,062. 5062.
So at the end of the product, you got the value of mm, right?
Yes, doctor.
Okay, so what's the unit? So what's the values now? Zero 0.16 mm. So everybody got the same answer?
Yes, for me, doctor.
Okay.
Doctor, I have a question. For the unit, isn't should be 1 over mm?
1 over mm. What? What are they?
For the unit, because it's kilonewton mm over newton mm square.
Uh-huh.
So it should be 1 over mm.
Times V2.
1 over m. What do you mean, Odai? Okay, so this is kilonewton meter divided with Newton per millimeter square. You change it to this Newton. You start with 1,000. So, but you multiply with the millimeter square here. So you got millimeter, isn't it?
Oh, okay. I thought this 1.1 is under the good.
So you forgot this one.
Okay. Thank you, madam.
Okay. So now you got the same answer, right? Okay, so means that the deflection maximum from the slab to 2.034 plus with the 0.16. So the ones that you got here is 2.194 millimeter. This is only from the slab 1. Okay, so by using the same method, you have to calculate for the slab 2. Okay, but now the slab 2 will be, okay, so but this one is going to be 1, and then your W will be 3 kilonewton per meter square times with the 1 meter. So you will got 3 kilonewton instead of 4.5. So now it's going to be 1 meter. This is going to be meter, 1 meter. And your W is 3 kilonewton per meter So by using the formula, W over 384 EI times the minus 4LB square plus with the B cube. So W, you should be change it to kilonewton. So 3 kilonewton per meter times with the 2 meter divided with the 384 E 210,000 Newton per millimeter square times with the I 1360, right?
Yes, yes, doctor.
Times with the 10 power 4 millimeter power 4. Okay. Times with the 8L squared. B is going to 2000 plus with the B. Okay, so 1, 2, and 3. So what is the 1? So 1 is easy. So 6 kilonewton. Okay, so what is 2? What is 3? So what is the 2? It's the same values with this one. Kan? Sama je kan?
Yes, doctor.
Yeah. 1.097. .097 Newton millimeter square. Sorry. Power 15, isn't it? Okay, so what is number 2 here?
Uh, 4.636
4.63.
636 times 10 power of 11.
Okay, units in millimeter cube, isn't it? Okay, so you can find the value of the deflection. What is the W now? Don't forget to change it in Newton, yeah?
Two point five three six
2.5
three six millimeter.
millimeter.
Yeah.
So, the same answer is others? Okay, second. So 1 meter, 2 meter, 1 meter. This is W over 2. Okay, so the formula is WA 120 EI times with the 16a square minus with the 20ab plus with the 5b square. So do this first. W, make sure that it's in kilonewton. So W is 3 kilonewton per meter, which is, this is 1 meter. So your W is 3 kilonewton per meter, right? Times with the, because of triangle, 1 meter. Okay, times with the A. So your A now is 1 meter. So I just change it to millimeter. 120 EI 1360 times. Okay, and then multiply with this one. 16. A is A. Yeah. A is 1000 millimeter square minus with the 20 millimeter. B is 2000 millimeter plus with the B 2000 millimeter power 2. Okay, do it one by one. So calculate this one first, 1, and then this part, second, this one, okay, this one will be this one berapa? Nombor 1. Number 2 is just the same with the previous one. So number 2 is 3.47. Power berapa ya? Number 2, 3.47 power what?
40.
14 Newton millimeter square times with the, so what is the value of the number 3 here?
Doctor,
I
I got negative 4 times 10 the power of 6.
Negative
4 times 10 the power of 6.
millimeter square.
Millimeter square.
Okay. So other got the same answer, right? So what's the values now in millimeter? Negative?
Doctor, I got negative 0.017.
Negative 0.07.
17.
Okay, so very, very small. So means that it's not deflect, it's going to be like a chamfer like that. Because the impulse is very, very light. for that type of the loading lah, only 3 kilonewton per meter. Okay, so that's why it's going to be like a chamfer. Okay, so the total from the slab 2 is deflection maximum from the slab 2 is how much? 2.536 minus with the 0.017. So how much you got?
2.366.
2.3.
366.
2.519.
0.17, right? Okay, so millimeter. Okay, so the total maximum from the slab 1 plus with the slab 2, how much? Slab 1 berapa tadi total? Cepat nak habis ni. Why the slab 2? Slab 1, 2.194. 2.194. 2.194 plus with the 2.519. So how much you got?
$4.713.
4.713.
Okay, millimeter. Check with the limit. Limit is 11.11 millimeter. Oh, banyaknya millimeter. Okay, so limit is bigger than deflection. So it's okay. So therefore, the calculation that we done for the restraint beam for that type of the load condition and the type of the value of the loading, so it passed. So 1, 2, 3, 4, 5 pass. Ultimate pass, serviceability limit state pass, so it's okay. You can use that type of the section. But if not passing, you have to go for this static switchable state. Okay. Any question? Aisalan? Aisalan tak? Kita ada masa ni actually. Are you sure? Okay, can I ask, how about the safe rate of beam? Is it why we didn't calculate for the safe rate of beam? For the deflection, why not? Kenapa kita akan calculate safe rate of beam? Why we are not included the safe rate of beam in the deflection calculation? Kenapa? Hello? Respond.
Safe rate is permanent load not.
Okay, safe rate is a permanent load. So permanent load is not, it shouldn't be included in the calculation for deflection. How about the brick wall? If you have a brick wall, does the brick wall also is a permanent load or imposed load?
Permanent load.
So yeah, brick wall is permanent load. So therefore, it's not included in the deflection calculation because code says that it should be just variation of the imposed load only. Okay? All right. So if there is no more question, I will end this session for today. So thank you for listening and take care and be safe.